Welcome to RPS Group of Schools online classes. This is session 4 for the chapter Motion and Time. In the previous session, we studied the measurement of time. We also discussed pendulum clocks which work on the principle of periodic motion of a simple pendulum. In today's session, we will study about simple pendulums. A simple pendulum is a device that completes its each oscillation in exactly the same time. Simple pendulum was first discovered and studied by Italian scientist Galileo Galilei. A simple pendulum consists of a heavy object called bob tied to one end of a light, unstretchable string. The bob of the pendulum hangs freely from the string. The other end of the string is tied to a fixed point as shown in the figure. The normal or the resting position of the bob is called its mean position. When the bob is released after displacing it from its mean position to either side, then it starts to move in a to and fro motion around its mean position. Such a motion of the bob about its mean position is called oscillatory motion. The figure given here shows the oscillatory motion of the bob of a pendulum. Suppose point O is the mean position and the bob is displaced from its mean position to point A on one side. When the bob is released, it crosses its mean position and then moves to point B on the other side. You will observe that the bob does not go beyond point B and then again comes back towards the mean position point O. Point A and B, beyond which the bob does not move, are called extreme positions. The motion of bob starting from point O to point A, then A to B via O, and finally back to O from B is called one oscillation. The number of oscillations in 1 second is known as the frequency of oscillation. The SI unit of frequency of oscillation is Hertz. 1 Hertz is equal to 1 oscillation per second. Similarly, 5 Hertz would mean that the vibrating object is completing 5 oscillations per second. Now let's do some practice and try to answer the following questions. What would be the frequency of oscillation for a simple pendulum that completes 2 oscillations in 1 second? Yes, the correct answer is 2 Hertz or 2 oscillations per second. Now let's try to solve another question. A simple pendulum completes 20 oscillations in 5 seconds. Calculate its frequency of oscillation. Let us discuss the solution for this question. We already know that frequency of oscillation is equal to number of oscillations per second. Since number of oscillations in 5 seconds equals to 20, number of oscillations in 1 second will be 20 divided by 5, which will be equal to 4 oscillations per second. Or alternately, we can say that the frequency of oscillation is 4 Hertz. Now try to answer this one. What would be the frequency of oscillation of a simple pendulum if it completes 30 oscillations in 1 minute? If your answer is 0.5 Hertz, that's correct answer. This means that such a pendulum would complete only half of the oscillation in 1 second. The time taken by the bob to complete one oscillation is called the time period of the pendulum. The SI unit of time period is second. Time period of a pendulum can be calculated by dividing time taken for oscillations by number of oscillations. Now let's try to solve this question based on time period. Calculate the time period of a simple pendulum that takes 10 seconds to complete 40 oscillations. Here is the solution. We know that the number of oscillations as mentioned in the question is 40. Total time taken for completing 40 oscillations is equal to 10 seconds. So by keeping the given values in the formula for time period, you will come to know that the time period of this pendulum is 0.25 seconds. The maximum displacement of the bob on either side of the mean position is called its amplitude. The SI unit of amplitude is meter. Galileo Galilei observed the motion of simple pendulums and found some facts about its time period. Pendulum of a given length always takes the same time to complete one oscillation. The time period of a simple pendulum does not depend upon the displacement of the bob. The time period of a simple pendulum with greater length is more than that of a simple pendulum with smaller length. Since we have discussed the measurement of distances and measurement of time, you will be able to calculate the speed of a moving object by using the formula discussed in the previous sessions. Observe this image. Have you seen this device before? Can you identify what is it? Yes, it's a speedometer. A speedometer is an instrument fixed in a vehicle that measures its speed in km per hour or miles per hour. An odometer is another device installed in vehicles to measure the distance traveled by the vehicle. That was all for today's session. Thank you.